And our first presenter is Dr. Sajad. Dr. Sajad will be talking on profiling to protection, leveraging datasets for enhanced IoT security. Dr. Sajad is currently an assistant professor of computer science and cybersecurity research and development team leader at the Canadian Institute of Cybersecurity, University of New Brunswick. He has more than 10 years of experience in the different fields of cybersecurity and has made a significant contribution to digital media security, artificial intelligence security, natural language processing, IoT security, machine learning based detection system. His expertise as a team leader has been vital in various prestigious organizations, including Kyushu University, University Malaya, Iris Smart Technology, and Kyushu Institute of Technology, Japan. He is the founder of several cybersecurity datasets in the IoT and the NLP security domains. Dr. Sajad served as the managing editor and the board member of the highest ranked Q1 journal of applied soft computing for over 8 years. His current interests include human-centric cybersecurity, AI-driven threat modeling, security architecture with large language models, and Gen AI algorithms. At this point of time, Dr. Sajad, I will open the floor to you. So over to you, Dr. Sajad.
Hey, thank you very much, Samit, for the nice introduction. I'm sorry about the date, it's 2024, obviously. All right, so CIC, as Samit mentioned, is famous for state-of-the-art data sets from 2017, and basically coming from a network security-based type of data set that are globally famous. But in these presentations, I try to go over the data set that we had for the past 3 years, basically mainly in IoT domain, and I focus on 2 of them. But before that, I have to explain a little bit once and for all what IoT is. So the Internet of Things, or IoT, describe the network of a physical object or thing that are implanted with sensors, software, and other technology that can sense for the purpose of connecting and exchanging data with other devices and systems over the internet. So the term IoT is mainly used for devices that wouldn't usually be generally expected to have an internet connection, and that can be communicated with the network independently, such as your fridge, for instance, 10 years ago. So IoT behavior is very important at this age because we have a lot of different devices that can be categorized in IoT domain. And for a very obvious reason that by end of this presentation, you will have a good comprehension of why IoT devices are very important from cybersecurity perspective, and why creating and having data set, up-to-date data set in this environment is very vital. So starting with why IoT is important. So many people are familiar with IoT technology for consumer market. These consist of wearable devices like your smartwatch, voice-enabled assistant for home, smart car technologies. But actually in 2022, if I'm not mistaken, it was estimated that each individual owns at least 7 connected devices. And you can see how much different people will spend in IoT each year, and this is by 2023. And this number of leverage in this environment, there is no surprise, because these devices basically are very convenient. And the convenience of these devices, when convenience comes in, the bottleneck will be definitely a hard thing for people like us, which is cybersecurity. So starting with what we do at CIC and CIC IT Group, again, CIC is, as Samit mentioned, we are a vast organization in terms of cybersecurity. We have several different areas of expertise, but we also created a very strong IoT team and extensively went into most of the direction in this area. But in this presentation, I'll try to show you one of the starting points of this area of IoT domain, which is IoT profiling. So as we started, we had the vision of understanding what is the difference between these new devices that comes in with no legislation, with no standards. And that's where it brought us to identification of these devices. It was a trend around at least 2 years to understand when you're monitoring your network, how you can differentiate actually between an IoT devices and non-IoT devices. And that comes to where you have the ability of creating and detecting different vulnerability. Anomaly and being very lightweight in this environment is very important. But there are several challenges in terms of understanding the life cycle of this environment. That's where it comes to several different research direction in terms of in terms of the category of these devices, in terms of the usage of these devices, in terms of how well maintained the brand of a device is. Again, the problem in this environment is when before 20 years ago, when you wanted to buy some technological type of devices, basically before iPad, we had PCs with 3 operating system at most and different brands, but the legislations and the standards to create the operating system was same throughout all these devices, such as either is PC or laptop. Problem in this environment is that there is no standard and any brand can comes in. These devices are cheap. These devices cannot be monitored like ordinary type of device that have operating system that are connected to electricity and have actually a CPU. So for device monitoring in this environment, you cannot use the IDS, intrusion detection system, such as like normal monitoring that you do, that you have normal firewall, you have malware protection on top of your intrusion detection systems, and then you are worry-free. Your admin, IT admin and vulnerability team are having no problem, because every time they actually do the vulnerability scan over your network, they have a good visibility of these devices. What's going on with this IoT profiling? And by the way, just as a fact, the first IoT device goes back to 1991, and it was an internet toaster. Then in 2000, LG announced the first smart fridge. And by 2005, UN published its first report on Internet of Things. Problem was, if from a start they put in a good standard in terms of manufacture of these devices, we wouldn't be in this mess, and I can call it a mess right now, and having no control over it. We cannot have an IDS, we cannot have a standard type of malware detection or malware protection or network monitoring, either tools or software or hardware, because of the same reason that I'm telling you. So this mess requires individual monitoring that we call IoT profiling. And to be able to do the profiling, you require to start from scratch, from the network traffic of these devices or different protocol that these devices have, try to identify them, and then you have to go a little bit further and try to understand the type of devices in order to understand the specific vulnerability of a device. So if there is a camera, if it's Alexa, if it's a smartphone, if it's a smart speaker, a smartphone is not IoT, by the way. So you actually require to understand the specific brands in terms of to be able to understand the specific vulnerability too. And unfortunately, for the same reason that I called this environment a mess at this time, no national database out there are able to keep up with publishing the vulnerability every day. And that's where it comes when we started 2 years ago as a team, and we spent 6 months. And that's actually very, very, very starting point that it just create a very important topic of understanding the life cycle of these devices and somehow try to generalize this environment in terms of the monitoring, and which we call it profiling. So basically, one thing is apparent in this environment, in any of these IoT devices. IoT devices basically have 3 different protocols, maybe 4, and 85% are network-based. The other one are ZP, Z-Wave, the much simpler protocol for sensors and everything else, and Bluetooth at the end. But basically, they have, this is what we identified, and this is what we felt the need to bring in a very generalized life cycle of these devices. And that's very, very, where we start with understanding and capturing the network of more than, for a first data set, which we call it IoT profiling, more than 85 different devices, basically off-the-shelf devices for a smart home, for a smart city, some of them, the wearable devices, and start from a beginning that your device connect to your network, which we call it a power experience. So we had these names for different cycles: power, idle, interactions. At least these 3 was the main one that we could categorize some of these devices, and we try to observe this the ability of these devices when they actually connect and interact. And the surprising thing was, even devices in the same category with the same brand, they react differently. Then we felt the need, if we are creating this data set for others and us to be used for some machine learning models, for some AI models to be able to train a sufficient, efficient model that cannot be overwhelmed with false positive and false negative. We try to, because even we started to monitor this behavior, and we could not generalize it. So we try to understand this device in different regions. So we had this vision of, probably if they are behaving differently, they might behave differently in different regions. And surprisingly, they did. So this first data set was using some of the same devices in our lab in Canada, and same devices in UK and US. And that was for the same reason. And again, we went for a one brand, for instance, Alexa, with a very specific instance of a brand, same brand at the same region, act probably same, but even the one that we had in here and US act differently. And even this every stage of this life cycle, from cybersecurity perspective, from detection, from model to be able to get as much information that they can, had different ideas. For instance, the power experience, the first 3 minutes of these devices connected to your network. And this is a list of the devices that we had for the first data sets. And this is the US lab and CIC lab. And these devices actually have to be maintained and have to be updated every second. But one of the interesting part of this observation was, for instance, this is what I usually mention for Alexa. When we did the power, when we did the interaction, when we did different scenario with this device, then we disconnected this device, and this was not part of the experience, but after the device was disconnected from electricity, from internet and everything else, after 15 minutes, this device keeps sending leftover packets. So that was where actually me and my team started to warn different industries that interact with us that how dangerous this environment can be, because of the vulnerability of this device. So one of the things was, for instance, this is one of the usage of this data set. we try to, because there is no data set, there is no generalized data set, there is no vulnerability updated every day. We try to generate a model that can identify the device, profile the device, and give you some of the possible vulnerability of a device in terms of how you can monitor. Actually, the good thing is today is a stream, and the next presenter will explain to you, Ali Reza will explain to you some of the usage of this pipeline and actually using this data set and how the devices can be monitored efficiently. So this was the first data set that we call IoT profile. Then it comes to the famous vulnerability and the famous trend of a research in this area, which is when you are actually getting an attack, when your network observe an attack. And this doesn't matter if this is in IoT environment, this probably have the same characteristic in the whole network security domain. Basically, to be able to train your model with clean data in terms of being able to classify either attack or benign for a binary classification. And if it goes to different variation of attack, then multi-class classification requires very clean data in terms of variation of the attacks. Most of the attacks are same in the ones that are applicable in the environments of network security for normal type of devices and IoT devices, but the same challenges applies here too. We require to understand if the classification, if you have anomaly models on top of your network and detect and big volume of attack, for instance, for DOS attack, you need to have a clear transparency and have explainable AI model on top of it. So same challenges, but here the difference is we have several different domains, such as when we come to Internet of Vehicle, that's another story. Same vulnerability applies because these devices, again, as I mentioned in the beginning, when a device have the same characteristic I just explained as an IoT, a simple device with an actuator or a sensor using some protocol to communicate with each other, but they are not being maintained regularly, and they cannot be identified by normal type of scan. They can be under umbrella of IoT. Same goes for Internet of Vehicles. Same goes for charging station, that one of the presentation and data sets are today. The third one is about that part. And same attack again applies. So APT at some point, when there is the presence of IoT device in your network, can react differently, and it is required to be looked at differently. And this lack of protection and having a 24/7 monitoring for these devices become overwhelming. Because if in theory this applies, and CIC is not about theoretical research, we try to come close to applied research. That means to be able to create a data set that can be used for lightweight models that can actually be used for 24/7 monitoring. But that is very expensive if your organization already have in place the network structure. That's some of these IoT profiling models and methods require change in segmentation of your network. So it comes again, this understanding the specific attacks in this environment become very important. One of these specific attacks are called Mirai. So I'm gonna just quickly explain what Mirai is. So Mirai is basically a sort of identifying a vulnerable IoT device by scanning those that can be reached using the internet. So in this case, this camera. By the way, 95% of cameras are identified as IoT devices. So once this device are identified, a brute force attack with a simple dictionary attack composed of factory default username or whatever it can be defined. It can be done much easier than the normal type of brute force attack that you do with normal devices with a CPU. And then this distribute the vulnerable devices and load the servers with Mirai. Load servers load the malware to a specific victim operating system. And once the device runs the malware, it becomes a bot. And it receives a new comments from the server. And which, by the way, Mirai also had the capability to eradicate other malware processes by closing all processes such as using SSH, Telnet, HTTP ports, for instance. And it just wait for the bot carry out the distributed, usually denial of service on the target, and they continue to scan and infect new victims and receive the instruction from the server. And that's where the organizations who are having these devices are doing. So this Mirai actually in 2016 shut down a large portion of internet, by the way, including 3 headquarter giants such as CNN and Twitter. And it actually brought down the electricity of a whole county of Liberia in 2006. And that's how important this environment is. And that's where our queue to have another data set in terms of different variation of attacks. So this is the second data set that we had almost 2 years ago in 2023. The goal in here was try to have the topology clear enough to be able to capture enough attack and capture enough traffic in different domains. You can see we are increasing the number. You have to do that every time. Even this data set can be obsolete if we don't keep maintaining, which we do at CIC. We are doing this. Again, that's why we have 6 different type of data set for past 2 years. In 2024 by itself, we are bringing 4 and we are working on 2 more, but working on the same structure so it can be updated in terms of having, for instance, in this one, we had 105 real IoT devices. One of the other challenges in this environment is most of the attacks are being carried out in a simulated environment, which we are going a little bit far from it. And this data set actually included the different variation of DDoS, DOS, reconnaissance, web-based brute force spoofing, and Mirai attacks that for a basic type of testing for a statistic, for not a dynamic data gives you very good results. So one of the other domain are healthcare. That's we started a project 6 months ago. Again, we had challenges of reacting with different type of devices in this environment. They had these different protocols such as Bluetooth, creating a challenge and creating actual meaningful attack for Bluetooth was very unrealistic in this environment. That made us make a lot of different type of attacks in this environment, but we did not stop, and we tried to do the same at 2023 in this environment. This is basically showing you the starting from 2022 until 2024, which we have the charger attack, we have a Canvas IOV, and we have 2024 healthcare data sets. So at the end, this is just a quick overview of what we did, why we're required to start from the profiling. This is one of the most important data set that we have, because it does not stop at attack, and it actually gives you the ability to have a good anomaly system over the behavior of your devices, and even track the movement of your devices and mobility of the devices. And this includes the attack data set that I just mentioned, and the IOMT or the healthcare devices require us to have a hybrid data set, including 40 different simulated and real sensors. The simulation is good. Simulation is important in theoretical research, in academia, probably. But when it's come to reality, being able to keep attacking a simulated device without bringing down the device is absurd. So that's why you require to have the real devices in your obsession. And this is what happened in IOMT, and this is what we did, and this is about how important these data sets are for different models, the actual models that can be lightweight enough and important enough to stop the impact in this environment. I'm not going to explain in details. The good thing, as Samit mentioned, all these data sets are free in CIC dataset page with very good support team at the back. Of course, all of them have a very comprehensive presentations on the website and the published paper beside it, explaining every little bit of it. So having worked on IOV and EV chargers and other devices, that other environment that we are not stopping, is giving us a good ability to cover this environment. And I'm very proud of our team and very proud of the achievement for past 2 years. And good thing is we are going strong, and hopefully we can have more up-to-date data set in future. Thank you very much.
That was really insightful. I would certainly be very careful when I'm buying my next IoT devices. We certainly live in scary times. So let us see if we have time for to ask our viewers question. It does seems we have a couple of minutes before we move on to the next presenter. So the question from one of our viewers is, why did you choose this type of data set creation? And how can profiling be used in different real life scenarios?
All right, that's a perfect question. Again, what I keep telling my team, the one that were with us from the beginning, and the starting point of this profiling, which was excruciating. We had people had to, just to make this data set realistic, had to sleep in our lab for some time because of these interactions. And because we were capturing 24/7, at least for two weeks straight, 24/7 behavior of these devices, and we wanted to be as realistic as it can be. One of answering your question is for profiling. Profiling is multidimensional. Profiling is not for one purpose. Profiling is not only for your malware detection or monitoring algorithm. This profiling can be used for anomaly detection at a very low level of understanding. If a sensor in your environment try to connect to a server in, I don't want to name a country, in a bad country, for instance. We don't have a bad country. With a trade actor at a country, for instance, that you are not aware of, then this profiling gives you ability to understand any type of anomaly in that terms. So anomaly basically, specifically for anomaly detection method, have different meanings. But this IoT profiling make it more meaningful. And I think from the citations, from the understanding, from some meaningful paper that came out of this data sets, I have a good understanding that it is really very close to be used in industry, and that was the reason that we use these different ones. And we have to keep going. We have to keep maintaining, updating this data set, and come up with the new ones, because new devices are coming out like mushroom from everywhere. And these IoT devices, as you mentioned, are bad news. They're vulnerable. They do not have the capability to be protected individually, and they would not be visible to your normal type of network scan. That's the scariest.
Thank you, Dr. Sajjad. That was really insightful, and I must say, you have set some really high standards for our next presenter to live by. But thank you for your time, and thank you for your insight as well.
Thank you.